All right, hi everybody. It is time for us to take a look at the 6-3 worksheet about properties of parallelograms. Starting with 14, in the statement shown, explain the student's error. What shape is the quadrilateral? So the student has said that JK is congruent to KL and LM is congruent to MJ, and angle MJK is congruent to angle KLM. They say, therefore, the two triangles are congruent by side, angle, side, which is true. We have side, angle, side congruence. The triangular halves of JKLM are congruent, so JKLM must be a parallelogram. That is the incorrect part, because they identified pairs of adjacent sides, which are congruent to each other, rather than pairs of opposite sides. So even though the triangles are congruent, they do not come together into a parallelogram like that. They actually come together into a kite shape, like this, where we have two triangles that are congruent there. So we're going to say the student observed that adjacent sides are congruent. The student observed that adjacent sides are congruent and opposite sides are not. The shape that they made is a kite. So the shape is a kite. All right. Number 16, in a parallelogram, opposite sides are congruent and opposite angles are congruent. If all sides in a parallelogram are congruent, are all angles congruent also? Draw a picture to explain your answer. So we're going to have to try and draw a picture that either proves this or shows that even if all the sides are congruent, the angles don't have to be congruent. And that's pretty easy to do, because if we draw a rhombus, that by definition has 4 congruent sides. However, it does not have 4 congruent angles. So there's a rhombus. We can mark all these sides congruent to one another, but the angles are different. So we can say no, a rhombus disproves that. Number 18, what are the values of AB and DE in parallelogram ABCD? So if we take a look at this parallelogram, we know some things about parallelograms. We know that the opposite sides of a parallelogram are congruent to one another. So 24 for BC is going to be the same as AD, which means ED is the same thing as 19 plus blank is 24, so that's 5. So DE equals 5. And then it asks us what is the value of AB, and since opposite sides of a parallelogram are the same, that is also going to be 13. So AB equals 13. Number 19, quadrilateral EFGH is a parallelogram. What is the measure of angle F? So here, of course, we have to find what Y stands for. So we can set these equal to one another and say y plus 35 equals 2y minus 47, and we can solve that equation. Wow, hold on 1 second. There's no reason why I should make mistakes like that. So 35 equals y minus 47. Add 47 to each side. We find that y equals 82. Once we know that y equals 82, that's not the answer, because we need to know what the measure of angle F is. So the first thing I'm going to do is I'm going to find the measure of angle E. I'm going to say y plus 35 is the same thing as 82 plus 35. And that is going to be, let's see, 117. So angle E is 117. But we want angle F. So we're going to do 180 minus 117 because adjacent angles of a parallelogram are supplementary. And that's going to give us 63 degrees. So finally, the measure of angle F equals 63 degrees. Number 20, quadrilateral MNPQ is a parallelogram. What is NQ? So we know that the diagonals of a parallelogram bisect one another, which means x plus 6 is the same as 10. So x plus 6 equals 10, which of course means x equals 4. Once we find that, again, we're trying to find NQ, so we're trying to find the other diagonal. Remember that the diagonals of a parallelogram are not congruent. So we're going to take this, x equals 4, and plug it in here for 2x. So that would be 2 times 4, which is 8. So from the center to Q is 8, which means, since this is bisected, that from N to the center is also 8, and NQ, that diagonal, is equal to 16. Number 21, the figure below can be divided into two parallelograms. What is the angle measure at the bottom of the Simple, because the opposite angles of a parallelogram are congruent. So 40, and then on the other parallelogram we say, well, if this angle is 125, the adjacent angles are supplementary. So the angle down at the bottom here is 55, which means our angle is 40 plus 55 degrees, which is 95 degrees. All right, number 22, find the perimeter of a parallelogram. Got a few different things to do here, a few different things to find out. But I do know that a parallelogram has sides, or not sides, but diagonals that are bisected. So I know that if this is 3, then the upper part is 3 as well. And I know that this whole length is the same as 2a plus 4. So I can say 6 equals 2a plus 4. Then solve that equation. So subtract 4, 2 equals 2a, 1 equals a. So a is 1. So anywhere else I see, why does that not make sense? Hold on. Oh, because it's 2a minus 4. Like I said, sometimes this happens. That's okay. So we've got, instead, 6 equals 2a minus 4, which means we'll add 4. So 10 equals 2a, divide by 2. 5 equals a. So anywhere I see an a, I'm going to write a 5. So in this spot, for example, this is a minus 1, so that is 4. And then I need to continue on. So I also know that the diagonals get bisected. So I know that 4 is equal to 4b minus 6. Then I'm solving for b. So add 6. 10 equals 4b, divide by 4. 2.5 equals b. So anywhere I see a b, that could be a 2.5. For example, in this spot, which is 2b, that is going to be 2 times 2.5, or 5 units. And since I know that the sides, the opposite sides of a parallelogram are equal, then I can say 5 equals c minus 2. So 5 equals c minus 2. Add 2 to both sides. 7 equals c. All right, so this side is 12 minus 7, or 5 units. And that tells us that actually all 4 sides of this parallelogram are 5 units, which makes the perimeter 5 times 4, or 20 units. Kind of a lot going on in that problem. Number 24. All 4 arms of a mechanical jack are the same length, and they form a parallelogram. Turning the crank pulls the arms together, raising the top of the jack. How high is the top of the jack when the crank is 5 inches off the ground? And explain. Well, this is easy, because we know that the diagonals of a parallelogram bisect each other. So if this space is 5, then the top space is 5 as well. So we can say 10 inches because the diagonals bisect one another. 25. The handrails for a steel staircase form a parallelogram ABCD. Additional bars are needed 1/3 and 2/3 of the way up the stairs. Explain why the additional bars must be the same length as the end bars. So why are these bars the same length as bar AD and bar BC? So we know that the new bars are parallel to the other bars. And since that's true, we actually have 3 parallelograms here. So we'll write that down. The new bars are parallel to the other bars. The new bars are parallel to the other bars. So ABCD is divided into 3 parallelograms. So ABCD is divided into 3 parallelograms. And we know that the opposite sides of a parallelogram are congruent. So if this is a parallelogram, BC and this side must be congruent. If this is a parallelogram, AD and this side must be congruent. So we can state that since opposite sides of a parallelogram are congruent, that means all 3 bars must be the same length. All 3 bars, not all 3 bars, all 4 bars. What am I even thinking? I can, of course, count. All 4 bars must be the same length. All right, keeping going. This one's easy. Find the values of A, B, and C in the parallelogram. We know that diagonals bisect each other and opposite sides are congruent. So we know that A equals 12.8, B equals 10.4, and C equals 5.2. You almost don't have to do anything in that problem. And 28, in parallelogram ABCD, which angle is congruent to angle ABC? Seems like this might be a good place for us to draw a parallelogram. Well, not a square. Let's see. There we go. So we've got a parallelogram here. This is parallelogram A, B, C, D. So angle ABC is right here. The one that's congruent to it would be its opposite angle, which is ADC or CDA, depending on how you read that. So that would be letter B. And that's everything for this worksheet. Let me know if you've got any questions the next time you see me. Thank you. Have a wonderful day.